and the status of our trout and salmon population has been such that our anglers have been able to experience some record and near record catch rates for all 4 of these species I'm going to talk about today. 2015, we have some different trends than what we've seen in recent years, so I'll be talking about that. But first, I do want to acknowledge my co-authors, Mike Ewell and Jeremy Holden with Ontario Ministry of Natural Resources and Forestry, and Scott Prindle with our Region 7 DEC office. So as far as the data I'm going to talk about today, we have creel survey data from lake angler surveys, this being the DEC fishing boat survey. And Ontario also has an open lake angler survey, which hasn't been conducted since 2013. I believe it will be done this year? Yeah. And tributary angler survey data, that's somewhat limited in the amount of information available, but for the New York data, where we actually are fortunate to have a tributary creel going on that we started in fall of 2015, those results so far are consistent with what we saw in the open lake. So angler surveys, the shaded area here is Ontario's open lake angler survey. I won't be saying much about that today. The blue shaded area is where we conduct our Lake Ontario fishing boat survey, April through September, Niagara to up to the Eastern Basin. Ontario was fortunate to have started a tributary creel survey, and I believe the plan is to conduct that every 3 years. That was conducted fall of 2014 through May of 2015. At 10 tributaries, there are other tributaries that were not included. These are the 10 that they surveyed, and I just want to point out, with my lack of a pointer, Credit River and Ganaraska River, those are 2 tributaries I will be mentioning later. On the New York side, we have 5 years of tributary creel data. Most recent survey, again, we're in the middle of it right now, so we do have fall data from 2015. Some of those surveys, we surveyed as many as 30 tributaries in 2015. We're surveying 21. Here are just a few of the major tributaries that are being surveyed, and the Salmon River is a place Mike's already pointed out in his presentation. I'll be talking about that later today as well. Other sources of data: Credit River Chinook returns, Ganaraska steelhead returns, and Salmon River hatchery returns of Chinook and steelhead. So first, let's talk about Chinook salmon. Based on our fish community objectives, we want to manage the lake such that we're maintaining a Chinook fishery and also, very importantly, maintaining a predator-prey balance. For indicators of those things currently, we're looking at angler catch rates as well as growth and condition of the Chinooks. So I'll be talking about that today. Several of the graphs I'll show you are similar to this. It's data from our fishing boat survey. It's showing you the charter catch per angler hour of each of the species I'll be talking about, and this is a seasonal value, April through September, Niagara to the Eastern Basin. And I think we all know, Tim nicely showed it with his presentation yesterday, there's spatial distribution, whether you're talking chlorophyll A or you're talking, as Maureen showed, rainbow smelt or alewife, things aren't distributed evenly in the lake, and we know that's true of our predators as well. And where anglers are fishing and when they're fishing really influences the quality of fishing that they're experiencing. In 2015, we had fantastic Chinook salmon catch rates in May into early June on the west end of the lake, and good to excellent Chinook catch rates on the eastern half of the lake during that same time period. But the rest of the season was relatively poor fishing quality for Chinook salmon. And this raised some concerns, understandably so, amongst anglers. Where are the fish? Are there fewer fish out there? What's going on? And we can't definitively say the cause of that, but we do know we came off of 2 very cold years. Perhaps water temperature patterns were different. Perhaps wind directions, intensities were a bit different. Perhaps the numbers of predators out there, Chinook salmon out there, was lower. These are things that we are thinking about. So for the last 13 years, we have had the highest Chinook salmon catch rates on record, on average, more than twofold higher than the 85 through 2002 time period. 2015 was the lowest point in that recent time period. For the tributary creel data I'll be showing today, all the graphs for each of the species will look similar to this, where we survey several tributaries, and all tributaries are giving us different catch rates. It depends on several factors. What are the regulations? How large is the tributary? What type of anglers is that particular tributary attracting? How much habitat is there? So today I'm just going to focus on Salmon River, which is the blue dots. This is fall data. And again, Ontario was able to conduct a tributary creel in 2014, so I've got the Credit River and the Ganaraska points on there as well. And for all the surveys, or all the tributaries that we surveyed, we saw a range of catch rates. In fact, for all of the years that we conducted the survey on the New York side, there were several tributaries that had much higher Chinook salmon catch rates than what we see in the Salmon River, which I think most people tend to think of as one of our best Chinook salmon tribs. But as far as results, I do want to point out 2015 Chinook salmon catch rate was the lowest that we've seen for this limited data that we do have. And recall during those earlier years, 05, 06, 2010, 2011, those were years when we had record high catch rates of Chinooks in the lake. And Ganaraska in 2014 actually had, for the Ontario tribs that were surveyed, has the highest Chinook salmon catch rate for that year. We also want to track the growth. Typically what we show is the average weight at age 3, but what I'm about to say applies whether you're looking at the average length or the average weight at age 2 or 3. Our Chinook were smaller in 2015. The blue line is showing you that average weight of Chinooks in the lake in August, and the green line is showing you the average weight of those fish once they've made the journey, over 7 miles to the Salmon River hatchery. In 2015, Chinooks were smaller. Ontario has looked at the otoliths in Chinook salmon, looking at the mean in-year growth determined from age 2 to age 3. These are otoliths pulled from Chinooks returning to the Credit River, and that also showed that the two most recent years, which would be 2014 growing into 2015, were below average. Another indicator, yeah, the Chinooks were smaller. However, we also want to know about the condition of these fish. And although they were shorter, they were plump. The blue line again is showing you the lake data, orange line is showing you the Credit River, and the green line is showing you the Salmon River data. This is predicted weight, or the condition of a 914 millimeter Chinook salmon. 2015, the lake and the Salmon River returns were above average, but the Credit River also showed an increase in condition. So the Chinook were in good condition, indicating that there was food out there for them. So why were they shorter? Well, this winter's been quite mild, but we know the previous 2 winters were long and cold. We had near record ice cover, which is going to slow the metabolism of the fish. So we do suspect that those 2 cold years, and plus we had much colder than average summers during 2014 and 2015, we suspect that contributed to the reduced size of the Chinooks. Coho salmon, we also want to manage in a way where ultimately we want to maintain a diverse sport fishery that includes all these species of trout and salmon. Coho, we do want to be able to maintain or perhaps improve angler catch rates in the lake and tributaries. Coho in 2015 in the lake, the catch rate was 57% below the long-term average. Lowest we've seen since the mid-2000s. This was right across the board, so no matter what region of the lake you're looking at, our Coho catch rate was down. I did look at the stocking information. Could we have had fewer cohos stocked for, typically most of the cohos anglers catch are age 2 fish, so we can go back and look at the 2013 year class where those stocking levels at target level, and we actually, the fall fingerling stocking for that year class was on target. The spring yearling stocking, we actually stocked about 40,000 fish above our target. So perhaps there were fewer fish, but perhaps again, maybe there was a distribution issue. For the Salmon River Hatchery returns, the coho were there. They had plenty of cohos returning to the Salmon River Hatchery to get their egg take. But if you look at the tributary creel data in fall of 2015, we did see a lower catch rate in the Salmon River. And again, there's a nice range of catch rates for coho that we saw in the Canadian waters 2014. You'll notice a trend here. Ganaraska, for all of our species, in this particular year, we had higher catch rates of each of our trout and salmon species. So what about the size of the cohos? Here you're looking at the average weight of age 2 cohos in the Salmon River Fish Hatchery, record low levels in 2015. We also saw poor growth from the data we collected during the lake creel. So cohos were also shorter, but when you look at the condition of the cohos, just as we saw with the Chinook salmon, the condition of these fish was good. Rainbow trout. We want to maintain a rainbow trout fishery. A couple of our indicators here is we're looking at angler catch rates again, but we're also looking at trends in, we have a population index from the Ganaraska River returns. Also, what are we seeing for growth, recruitment, and I'll also be touching on thiamine deficiency issue that we have documented for salmon, or steelhead returning to the Salmon River. First, looking at the angler catch rates in the lake, 2015 was 39% below the long-term average, and this follows several years of near record high catch rates right up through 2014. Our catch rate in the lake was down among the lowest levels we've seen, it's the lowest we've seen since 2005 to 2006 time period. And if you look at the tributary creel data for the Salmon River, you'll notice the 2015 value lower than those record highs that we saw 2010, 2011 in the lake, but comparable to what we saw in 2005 and 2006. So again, the trib creel data is trending similar to what we see in the lake. And the Ganaraska River, which is really known for its spring rainbow trout fishery, here I'm presenting fall data, but that spring fishery was fantastic in the Ganaraska as well. Notice the Credit River runs of steelhead there, or rainbow trout there, are higher than what we've tended to document for the Salmon River, but if you look at some of our other tributaries, we do have higher rainbow trout catch rates in those other tributaries than what we saw in the Salmon River. As an index of rainbow trout abundance, we have the estimated run at the Ganaraska Fishway, and this trend is similar to the catch rates that we see in the open lake creel. When that's higher, or when our lake creel catches are higher, we do tend to see higher runs at the Ganaraska. And with rainbow trout is a very important fishery on the west end of our lake, and it's a very important fishery on the Canadian side of the lake. One thing I do want to point out here with the rainbow data, these are fish returning in the springtime, so this is spring data that I'll be showing you for Ganaraska River as well as the Salmon River. So in spring of 2015, run indicated that the rainbow trout populations was lower than it was for the previous 4 years, indicating that, yeah, perhaps we did have fewer rainbow trout out there this past year of fishing. We look at the size of the fish. Here we have the mean weight of age 3 and 4 rainbow trout returning to the Salmon River Hatchery. The circle lines, the blue and the green, are the males. They did indicate perhaps a decrease in size, but the females are similar to what we've seen in recent years. And looking at the lake data that we collected in 2015, it indicated that there was no change in growth for the data that we have from that survey, suggesting, well, maybe there was a little bit of a drop, maybe more so with the males. But the condition of the rainbow trout did decrease. In the lake fishery, we saw record low levels of condition of rainbow trout in 2015. In spring of 2015, when they looked at the condition of the rainbows returning to the Ganaraska, it was at record low levels. As I'll show in a moment, we know there was a thiamine issue, at least in the Salmon River, with some of our rainbow trout, so perhaps that's contributing to what we see here. So fall of 2014 through winter 2015, we were getting numerous reports from anglers and guides on the Salmon River that there were distressed and dying steelhead in relatively large number. Of course, this is a concern. We got samples in for disease screening, and they tested negative for any pathogens. The next thought was, well, perhaps it is a thiamine issue. So for starters, they injected fish that returned to the Salmon River Fish Hatchery with thiamine, and they immediately recovered. Samples were sent to USGS Wellsboro for tissue analysis, and they indeed found low thiamine levels in the liver and muscle tissues. And Cornell also did some analyses looking at glycogen levels in the liver, and they found lower levels there and nerve damage in the brain. And Cornell actually looked at Lake Erie and Lake Ontario samples. The Lake Ontario samples showed the depletion in the liver and brain damage. So it does look like a thiamine deficiency problem. So immediately started making plans for conducting a thiamine analysis. Currently, there's a contract in development where SUNY Brockport is involved, USGS at Columbia, and Cornell University will be collecting alewife and our trout and salmon species beginning this year to evaluate the status of thiamine in those fishes. Moving on to brown trout, very important spring fishery on our side. Less of an important fishery on the Canadian side, but they're going to be reallocating their stocking towards the west. And for brown trout, we also want to maintain or increase angler catch rates in the lakes and tribs. 2015 catch rate was about 27% below the long-term average, the lowest we've seen in a while. And for brown trout, just like with coho, typically the majority of brown trout that the anglers are harvesting are age 2 fish. The last 3 years, we've actually seen a higher percentage of 3-year-olds in the angler harvest, but I went back to the stocking records, and for that 2013 year class, it would have been 2-year-old fish in 2015. Our stocking level was about 60,000 short, so it's possible that that may have contributed to the reduced brown trout catch rate that we saw. But again, we do have those other unknowns out there and can't definitively say what happened. Looking at the trib creel data, 2015 in the Salmon River, just like we saw in the lake trib, lower catch rates. And again, a nice brown trout fishery in the Ganaraska, similar to what we see in previous years in the Salmon River. And again, you know, they're different types of tributaries, but it's nice to see catch rates like that. So just to sum up, for all 4 of our species, angler catch rates were down. For less so with rainbow trout, but Chinook salmon, Coho salmon, and brown trout, the fish were smaller, so their growth was slowed. We suspect that is at least partly attributed to the colder water temperatures we saw. Coho and Chinook salmon, however, condition was good. That was not the case for rainbow trout and brown trout, though, where condition was much lower, and rainbow trout, the lowest we've seen. So what happened? Well, I mentioned what potential of weather impacts, possible wind impacts as far as the quality of the fishery. We know that our fish are not distributed evenly in the lake, but maybe were they less concentrated? Were they in places that they aren't normally at? Was the distribution of the prey fish a bit different in 2015, which would then lead the predator distribution to be different? Maybe they were less active, or feeding less with our colder water temperatures we saw in 2015. There are a few things that do suggest that perhaps the abundance of at least some of our predators were lower than what we have had in previous years. So with that, I will take some